can it be? I think I told most of the points I had to say about Go on Thursday. If you have not seen that video, it's there on the channel. You can easily go and check it. So today I'm going to approach Go from a different perspective, and it is a perspective that a lot of people actually have. Um, and that perspective is career, right? Because uh, from what I see, a lot of people on the spot are the people who are either a couple of years, 3 years or so in experience, or some are still in college, or you know they are looking for a career change. So career is a big part of why we do the things that we do. And one question that I was asked a lot was, how will Go help me get a good career? So I want to elaborate on that. If you have got any question, let me know right now so that I can cover it. I am focusing on Discord chat. Okay, the same old thread that was there. So if you have got questions, I will be looking there. Uh, okay. So when it comes to career, you have to understand that it's a game of supply and demand. If you go out today saying that you know C, you don't have a lot of jobs. If you go out saying you know Node, there are quite a bit of jobs. Python, a lot of job listings will say Python is a requirement. They'll say that Ruby on Rails is there. There is no uh, what else? Java. Java is a big one. A lot of backends are being made in Java. So if you want to get a job, you go by the job requirements on popular job forums like say Trust or Naukri or what do you have like Angel is there, and so many others. There's Cut Short and a few others, right? The consensus is still about the same. You have got Node, you have got Java, you have got Python, and I think the large portion of a lot of newbies, they just know Node, right? Um, and part of it is because people are lazy. I'll be honest, this is what I find. Because the biggest argument that any newbie would give is, you know what, JavaScript can do server, JavaScript can do client. I can make a mobile application in JavaScript if you know React and you know React Native because the APIs are all in JavaScript. If I know JavaScript, I can do it all. Well, first of all, it is true to an extent, but JavaScript is was designed for front end. It was designed for browsers. So it is really geared towards that usage. For example, you do something and you don't wait for it, right? You send it to background immediately. So to synchronize everything, making callbacks, making promises and stuff like that. Whereas in backend, you don't always do things like that. You get a request, you process it step by step, you will go through all the checks in certain steps, and only then will you do it. So if you know Node and you look at Node code, it would be very different from any other programming languages code, like Python or Java or Ruby or PHP or anything else, right? Go is in that category, the same category. It doesn't do a lot of callbacks and stuff. But at the same time, the reason why Node becomes really, appealing to a lot of people is, well, there are two big reasons. One, it's said that Node is performant. Well, compared to certain languages, it is not. I mean, there is usually one receiver thread, and you can have some worker threads over there, worker pool, and you can make those work together, but it's a little bit hard. Also, it depends on promises and stuff. So the architecture is different. So speed is taken care of. You have competing languages, and the other is uh, basically being able to do multiple things because you can send things in background. And Go is probably the closest you're going to get to those both of those points if you look at backend languages. So Go is a perfect replacement for Node. Now, JavaScript is by essence an interpreted language. Go is not. So at any place where you don't want your backend to contain your source code, you do not use any interpreted language. That includes PHP, Python, Ruby, and the likes, and JavaScript. Go compiles to binary, right? And like Java, but Java's binary is basically a bytecode. So as the number of people now, I got here from the demand supply perspective, right? Can you repeat last sentence, please? I don't remember what I said last sentence. I was basically stating that the JavaScript is interpreted and it will have the same problems as an interpreted language. The big one of which is that you need to have your source code on the server when you are running it. You can't delete the source code, compile JavaScript into something else like a binary or a bytecode and then run it. That's not possible, right? So that was the last sentence. Now I got here this point of argument from demand and supply. Since the number of people who know Node increased, a lot of other people thought, okay, since I can get cheap labor at for Node people because there are college graduates, just freshers, I can get hire them for cheap. Uh, they probably made it in Node. Some people who just got out of college, they created their own startup from wherever. I mean, I don't know where the funding comes from, to what money from whom. But a lot of people who come out of college, they make a startup. And since they know JavaScript, they think that it's a magic bullet. They start off with Node. And so you see a lot of job openings, especially on places where you have got a lot of startups posting jobs. They'll have lot of Node listings. These are the companies in their first 1, 2, 3, 4, 5 years of existence, not beyond that. Beyond that, if you start looking at a company, you will see diversification. Either you'll see diversification or you'll see death. Either the company has become really big, they have made it, and they are now in need of other, multiple technologies, multiple services are being brought up, or they're like dead in the water. They're going to close shop. So Node is good. I'm not saying Node is bad, but as you move ahead, the requirements change. The requirements change from being able to churn out code to make good programs. You don't. You can rewind. Oh, okay. So you can. The requirement changes from writing fast services to writing good services. Writing, making the feature work to making the feature work flawlessly. This is the shift in requirement that will happen as you go in the progression of a company or a service. So Go probably won't get you into a lot of startups. There are startups that use Go, and Go is one of the perfect languages out there for backend. I'll give you the reasons later on. But Go is not at least in my observation, Go is not the prime language that startups prefer to use because of non-technical reasons. They use because whoever was the creator then use something else. Java is taught in colleges, Go is not. So Node and Java are basically the two things that I see a lot of startups starting off. Right. So where does Go stand career wise? Go stands career wise in stable places. This is what my understanding is. This is what my observation is. Anyone who has just taken the decision of using Go either has a sound technical background, he understands what he's doing because Go again, like I said, Go is not being taught in colleges. Go is not being taught in universities. Uh, People who just came out of college, they are not supposed to know Go. They're supposed to know Java, and since Node is easy, they probably try it. But if someone has taken the chance or the decision to build a service on Go, either they have enough money that they now want to optimize and take control of a lot of chaos they have created in the past, or they want why most. Okay, I'll answer you, Aditya. So Go is used by people who have got more maturity. That is my understanding. Um, Aditya said, I don't understand why most startups don't use it. You can iterate at same speed at with Go, that's better concurrency. You can iterate at better speed with Go. It's not the even same speed. If you bring in someone who has got like 5 years of experience in Java and 5 years of experience in Go, I do believe genuinely that a person who has got more experience, like same experience in Go, will start writing better code. Um, and with time you'll understand why I'm saying so. And the reason I said most startups don't do it because see, startups are created by people, right? Where do these people come from? Startups are not made by very old guys. They're made by people who are you can still be called, garam khoon in Hindi, like hot blood. They still want to do some. They want to make a change. They want to create their own service for something. They want to solve a problem. So this kind of people are usually the people who have just started out. And in college, you are basically taught C. C is impractical if you want to, build a web service. It's possible, but it's impractical because it takes quite a bit of time to actually build a service in C, pure C. So people take the other language that they, study in college, which is Java. So Java is one of the bigger candidates. The other is Node because Node is JavaScript, and JavaScript has positioned itself over time as a language that can be used to build approximately everything: mobile apps, web app, backend, everything. So a lot of freshers, I've seen this in freshers, this argument coming out of freshers a lot, that if I know JavaScript, I can do anything and I'll probably get a job as whatever. They're looking for a job, right? Not everyone is passionate towards one particular technology or solving a particular problem. A lot of people, I think it would be fair to say most people are there to just have a job. So they're looking for a job and they think that if I master JavaScript, well, you can't master something in a year or even two. Uh, but if I learn JavaScript, it gives me a better chance at landing a job even as a mobile developer, as a front end engineer, as a back end engineer. That's what people think. Is my observation personally. So I could be wrong on certain points, but this is my observation. And this is why the startups that new startups they start with either Java or Node. And Python is about the same. Python is easy to learn, easy to command. You can start writing beautiful code in Python. It's also indented beautifully by default. So that's an added advantage. So that is the reason. Now, coming back to the point, when you are looking for career in Go, Go is being, like I said, I'm just repeating myself, Go is being used by people who have taken the decision to use a particular language, Go, right? They usually don't start off with. So Go has to have some advantages to it, which is why it's being picked up by experienced people. People don't usually build in Go, they shift to. I have seen this happening in a couple of companies, and I do think it's a fair deal that people shift to Go, they don't start off with. Now, if you learn Go, what kind of engineer would you be? Go is a backend centric language. It was built for backend. So I have written an introduction to Go. I will again. I have done this entire, kind of read, but I explained everything, and I'll go through this transcript or post again. I'll also post it on the website. So if you go on opentechradio.in, maybe in a couple of days you'll have this over there, and maybe I'll even give the link to the video, and I'll go through it. But if you look at why Go was built, Go was primarily built to solve Google's problems. Okay, and I'm gonna just walk you through the same stuff uh, that I said in on Thursday. See, Google is big, right? And Go is Google's language. It is nobody's, uh, hobby to create a language. Creating a language is a daunting task, difficult task. Nobody takes it for fun. And when you have something like Google, Google is a for-profit company. It has got a lot of resources, but they also want to optimize the time they're spending, the money they're spending on something that is of value to them. Google created Go, which means it must have been doing something of value to Google, and it still backs. I mean, Google still backs Golang, and it still funds Golang. They still have engineers working on it. They have a dedicated team of people who work on Go. They manage the community. Why do they do? I mean, take so much effort to maintain a language which is open source? And also, the reason they make open source, anyone makes a language open source in the hope that it will find more users. One, it will find more use cases and more corner cases where the language could be improved. And this improvement is going to help the creator as well. This is one of the biggest reasons why something goes open source, especially a language. So why is Google doing it? It must be solving their problem. Think about it again. Go is solving Google's problems, and Google is big. So Go is solving some big problems. We have to understand what are those big problems. And before I proceed with that, remember what I just said. People shift to Go. People don't start off with Go. They will start off with Go. There are a lot of people who start off with Go. I'm not saying nobody does. I'm saying a lot of people start off with something else, which is churn out quick and dirty code. Let's get the service running. Let's make a website. Let's register some users. Then go to um, maybe an investor or be profitable kind of a thing. Like they don't start off with something very mature for solving a certain specific problem. So, what are the problems that Google was facing, which needed solved? When you start growing, as your scale grows, you will face some problems which will probably be solved by Go more easily than a language, any other language, because Go was designed to solve those problems, right? So, I want to finish the point that the train of thought that was there. Like, where would I end with Google? You will end probably at a company that is looking to expand itself, its services, and its methodologies with something stable, robust, and supported by a large company, a large community. And that is where Go is positioned. That is the kind of company you will land in if you actually work with Go. Okay. Now, let's get back to what kind of problems Go solved for Google. So I'll go here and I'll quickly run through the initial part of this introduction and tell you how I started. Okay. So you can read this later on. You can take a screenshot if you want or go through the video again. So why should we start with Go is the perspective of this article. And it starts with why Go and not why not something else. So before we get to that, we need to understand where Go is used, and you know that Go is I've already said Go is used in backend. So why backend? What are the different challenges of backend that don't occur with other software? So if you look at what other type of software is there, you've got desktop apps which basically focus on getting things done. They handle one user at a time, and they're supposed to be integrated with the OS as much as possible. Like I have Discord over here, right? If I take a drag, if I take a file from here and I drag and drop here, it should be accepted. If I double click, it should resize, right? Or at least the full screen should work. I should be able to navigate easily and stuff like that. So and desktop apps basically support one user. They are supposed to be integrated with the OS as much as possible, and they're focused on getting things done. That's it. They have a purpose. They do that purpose done. Like an example, a very good example is actually MS Word. MS Word is a behemoth. It's such a big app. It's GBs in size. It takes just as much RAM, and it helps you basically edit text. Right? People still pay for it because it solves their problem. Right? It solves a particular problem of word processing. Ishan, Nexus, Tej, I'll answer those questions in the end. Let me finish what I'm talking about. Mobile apps are just like desktop apps with a small screen and limited resources. I guess you can just think of these limited resources, and that's both of these points. Small screen is also a limited display resource. Web apps, other kind of application is web apps, and Web apps are usually not very super duper complicated. One of the good examples of a super duper complicated app is Postman. It has become real slow, and I would any day prefer to write a curl command than actually go with Postman. There are not other features over there. Um, when we talk about web apps, we also talk about things like Slack or Discord, which can load in the browser via a URL and then work. And when it comes to that, it's they are all written in JavaScript. If you're writing TypeScript, it transcribes to JS. So they suffer from the same performance penalty of JavaScript and the any overhead caused by the browser. So if your browser is behaving slow, your entire app is behaving slow, right? Again, a lot of desktop apps are also wrapped in Electron framework, so they are more of web apps or websites than they are like desktop apps like Word, right? So I mean, Discord is also a Electron app. And then another category is games. Like now, games are interesting because they push the hardware to their maximum. Usually, no other kind of app does what games do to the hardware. Like they ask for more RAM, they ask for more concurrent processing by a processor, they require graphics processing systems, they require parallel execution of a lot of pipelines and stuff like that, vector shading, physics engine. I mean, just look into the mathematics of how reflection and refraction work with water. Just to simulate flowing water in a game is a nightmare for people. I mean, people who do the maths behind all of that stuff, it's a nightmare for them. So games do a lot of stuff in parallel. Physics engine calculates movement of everything that you are seeing on screen and things that are not even on the screen. Graphics engine keeps talking to the graphics hardware, keeps sending it data so that it can be converted into a beautiful, you know, screen that you see. A network engine talks to a server. Which on do not disturb. Second. Yep. Input events, what's on user input, sound engine tries to give you the best sound, most immersive sound that it can. Okay. And they're famous for being the most demanding application. Now, backend is different. How is backend different? I'm going to take a Gmail as an example. So when you use Gmail or any email service for that matter, but we are taking Gmail because Gmail is widely popular. Uh, Even if you assume a billion users and you assume that one person receives one email in one day and he reads that email, then you have got 1 billion emails coming daily. And if you think of different stages of the email being processed, like it has to be accepted. Let's assume it's one operation. Now, the word operation over here is very vague term because uh, I'm not getting into how it's processed, how many different parallel threads, what the steps of the processing for each of these operations. For example, accepting the email takes three different subsystems working together for an email to be received. Right. Um, let's assume that's one operation. The email has to go through some filters, detection, categorization, validations, any rules that you put on, like put it in this folder, forward it to another email address, something like that. So those, let's assume five operations. I'm very sure. Then you have got the storage requirement. It needs to be stored somewhere. If it's important enough and you have an app, it will give you a notification. So that's another operation that has to take care of. Then it has, whenever you open an email interface, it will be opened, right? The list of emails will be opened. Um, that is another operation. And then you open the email, it's marked as read. That's another operation. So in total 10. So you've got, if we look at the mathematics, it's easily 10 into 1 billion. That's 10 billion operations happening every day. And that's approximately a little bit more than actually, I think it should come to somewhere around 113,000 operations per second. None of these class of apps, desktops apps, mobile apps, games, web apps, nobody goes through this torture. This right here. Nobody has that requirement. So backend is different from everything else that you normally interact with daily, right? This is the problem of Google. I took Gmail as an example because Gmail is Google's service, right? You are talking about a system which is being used by billions of people every day. It has to be reliable, it has to be performant, It has to do a lot of work concurrently. A lot of background operations are happening. For example, sending a push notification is usually a background operation. Um, you know, a lot of detection algorithms are background operations or things like that. Just excuse me, water. So it's different, right? Google solves this problem, right? If you are thinking of building something at scale, if you're startup, any company that you want to work on in is trying to create a service which it knows is going to be used by millions of people, then they'll probably go with Google would be the right choice for them. And this was Google's problem. So who designed Go? I mean, when we say Google designed Go, why did they design it? There had to be people who saw the problem. So one of those people is called Rob Pike. He is a blog post is Rob Pike. Let me do this. Rob Pike is the creator of UTF-8. Okay. So if you're able to send cute smileys and red roses on a plastic screen to your girlfriend because of Rob Pike, if I can type in Hindi or in Tamil or in Chinese, whatever kind of Chinese dialect that is, it is because of Rob Pike. There's a very interesting talk given by a brilliant speaker. Uh, I'm forgetting his name. It's titled as Plain Text. Okay. Um, let me just quickly search for it. Basically, just let me search for it. And I will tell you. Dylan Beatty. Okay. This is the talk. This is an amazing talk. Okay. You should go through it. You will see why UTF is a big deal. Before UTF, the standardization of multi-byte characters was not there. Like UTF stepped in and made it possible for computers all over the world to display all sorts of languages. You can today be almost sure that if you write something in Hindi or Tamil on your computer and you send it across to someone else, sitting somewhere else, having some kind of phone or a desktop, laptop, whatever, it will display it as it is supposed to be. Otherwise, you'll get all those blocky characters, right? So that's what UTF does. Um, he was also behind operating system called Plan 9. He has worked with Ken Thompson in the past, and Ken Thompson and Rob Pike worked with Dennis Ritchie, who is the famous creator of C. Ken Thompson himself is a creator of B. B is the predecessor of C. If you have had any kind of introduction class on C language, then you would know, right? So he was also one of the creators of the Unix operating system, which is a very big deal. I mean, if you have got Android, if you have got iOS, if you got Mac OS, if you have got Linux, except Windows, everything is Unix like. Unix is that phenomenal. Linux dominates the server scene, right? Unix like. Ken Thompson was one of the creators of that. And Robert Geismer is the reason why you have got V8. And V8 is what Node is based on. Okay. He worked on a Java virtual machine called Hotspot, which basically brought in the JIT capabilities and that made Java fast. And he's the third guy. Okay. Who is behind Go. You can read all of this at your own leisure. But if you look at what problem Go solves, right, you can see these are the features. right? You have got these three people. Robert Griezmann has not worked on an operating system, from what I can see, but he has worked on languages. Ken Thompson has worked on operating system and language. So has Rob Pike. And these are the major contributions of this. One thing that obviously this is not the entire set. These people are old. They have worked for decades. They have done a lot of other work. Okay, which I don't have the space to write actually. For example, Rob White actually wrote the first windowing system of multi windows. So if you have got one window, this is the window, right? And you want to take another window. Let's take the settings window, and you can do this one window overlapping another window. He wrote the first implementation of this thing. Okay, I obviously I don't have the place to show all of them. So if you look at this, you have people who are above. I mean, Ken Thompson right now is, I think, 80 years old. Rob Pike is somewhere around 70, 75. This is around 60. You've got really old people in their 50s or late 50s, 60s. They are trying to create a language. And they have worked on operating systems, windowing systems, languages. They have worked on compilers. They have done all this stuff number of times. Now, if you look at some big chunks of what an operating system does and what a language is supposed to do, you will see that operating system, first thing, resource utilization, that's the primary thing that operating systems take care of. Deadlock prevention and how to allocate what resource to whom. Inter-process communication, how to make two processes talk to each other, how to control them, how to schedule them, which takes priority over what. Then you have got robust network support. I mean, if the operating system today doesn't have a network support, will you even use it? No, right? Operating systems also try to take care of fast execution, but it's more of a language level problem than of an operating system level problem. On the language side, language typically tries to be as fast as possible. It should be able to compile fast. That's what every language creator at least aims for. They always try to improve the compilation time. And garbage collection. This is not every language's feature. I've just put it here because Robert Griesmer worked on Java, right? So you have these kind of things that these geniuses over time, over decades, have already worked on. And they have put all of those in Go. So Go has brilliant support for every one of these things. Every one of these things. You'll see that Kotlin has got coroutines. Java is getting something like coroutine as well. Some kind of a thread level control you'll see in Rust as well. These are newer languages. I mean, Rust is new. Java is not. Java is very ancient. Um, so these anyway, coming back, these are the properties where Go shines, right? So why did they create Go? Exactly. Um, I will show you the article. Command Center. This is the article that I have linked to in that post, and you should go through this, okay? And it will tell you why they designed Go. Basically, uh, yeah. So back around 2007, I was doing some minor but central. This is Rob Pike's blog. Uh, but central work on an enormous Google C++ program you have all interacted with, probably search. And my compilations were taking about 45 minutes on our huge distributed compile list. Think of this. You have a compilation cluster, it's not a machine. It's taking 45 minutes for you to compile that code. Don't you think you'll see a problem and want to like solve it? Go solves one of the things that it solves is that. Okay. And they also wanted it to be something that is picked up by people very easily. So a new person comes in, they just need to start a project with a new language. If you give him Go, he'll be able to start off really easy. That was one of the bigger targets. And they have achieved it because Go is one of the simplest languages you can ever come across, which is as much functional and as powerful. Go gives you really good built-in primitives for doing, communication either across multiple things running inside the same Go program, or two different processes, two different sub-services running. And do notice that Docker, etcd, Kubernetes, they're all written in Go. What do these guys do? What does Kubernetes do? It schedules pods. It makes sure that it tries to prevent deadlocks as much as possible. Resources are allocated really well. It makes sure that all the processes, all the pods are communicating with each other as much as required. It does networking, right? And obviously, these are the Go side of things, which is why Go shines. That is where Go shines, right? So Go has got, it's easy to use, fast onboarding because it's very simple. It's fast to compile because since the language specification itself is simple, the compiler does not have to do too much work. When it's compiling, the language is simple, so the AST stays simple compared to something like Java or Rust, C, C++ definitely. So these are complicated languages. There are too many features. So when the compiler is going through the code, it has to take care of a lot of things, analyze a lot of things. And then it comes to the stage where it actually, has the understanding, the entire understanding of the AST, and then it starts compiling. Right? So fast compile time, easy to use, fast to execute because it makes binary, native binaries. You can just take that binary file, like you download an exe file, you double click it on Windows and it runs, right? You don't have to do anything else. But you can't do that with a Ruby file. You can't do that with a Java file. You can't do that with a PHP, Python. You need to have their environments installed, right? You need to have JVM, you need to have PHP installed, Python installed, Ruby installed. And if you take a C program and you compile it, you can probably, like, if the targets are same, like if I compile it on a Intel Windows machine, I can take that binary file, that compile file, and I can give it to someone else and they'll be able to use it without anything else. Like double click it, it runs. Go will give you that kind of binaries, native binaries, right? And since it was solved to create Google's problems, it is really good with resource utilization. Even when it is garbage collected, its garbage collection is wildly different from what Java does in terms of performance. It's very easy to create web services. Like all the tools you need to create a website, a web service, a microservice, if you will. Uh, it's very easy to create it. Like all the pieces are right in the language. You don't even have to install libraries for most of the work. Networking is easy. It's very easy to create a TCP client, or a server, or a UDP client server, whatever. Massive concurrency. I mean, we once ran into a problem where we needed to do parallel computation, and it was a Ruby program that we were dealing with, and we started increasing the number of concurrent threads that were being run. We increased it from, I think it was set to 2, and we increased to 3, it scaled. Then we set it to 4, performance improved. It was not up to the mark. We wanted it to be faster. We increased it to 5. Brilliant. The performance is getting better. 6, the performance did not improve. When we set the number of parallel processes threads to 6, it did not improve. We set it to 7, it starts getting slower. Now it's spending more time. The program is spending more time managing those parallel threads than it is spending in the threads trying to do the actual stuff. So concurrency is important in case of backend. Go has got massive concurrency. I was supposed to stress test a particular implementation, and I just launched more than 3 lakh, 300,000 Go routines in parallel. I just launched them, all of them, all at once. Didn't break sweat, nothing crashed, nothing hanged, just went through like smooth butter. Okay. It just glided through that problem. I just got the result and I was like, wow. And this is something I had not imagined till that moment, doing in anything else that I knew. I mean, yes, it is possible in Rust, it is possible in C, but if you try to achieve that, you'll end up with something like You'll end up with a scheduling system. You'll end up with a, mutex kind of an object where you mutex is unlocked. You take a resource, you lock it, and then someone else comes in, tries to open it, doesn't open, waits, things like that. So I mean, this all that I said just now is basically what mutexes do, mutual exclusion locks do. And yeah, Google's problem, one of the centerpieces here is it focuses on API more than HTML. I mean, you can technically use Go to create the HTML rendering service, but Go's templating engine, I'm not very fond of it. Go's entire focus is not on rendering HTML, replacing the mustache type syntax and replacing it with the real variables and all. It can do that, but its support is kind of rudimentary. I don't like it. The focus, I believe, is on more towards the API things, more like creating backend services alone, rather than churning out HTML. I mean, you can even, I think, if I go to find.io, so if I go to find, you can, they say that easily build native apps that work everywhere. They're very good. You can actually make good apps and that, but it's cumbersome. I mean, you'll probably find it easy and more resources will be available to you if you try to use like Electron and React or Vue, TypeScript, things like that, than Go. So if that's the overview of Go from a few different perspectives than what I had talked on Thursday. On Thursday, I talked about mostly about the technical side. If you have not gone through all of that, please go through that video if you want, or I'll post it later, and I'll put the link in Discord. You can go through that. Okay, so who are the giga chat behind Go? I mean, I have massive respects for these people. And once you work with Go, once you know what these people have done, you will. So again, I'm saying lay back and think being one of those people. I mean, they have, I'll just read through it. So think again, you've got OS designer. OS knows how to handle too many things concurrently. Language designers, they know how to write a language specification in a weekend, probably. I mean, UTF-8 specification, I think they wrote in a restaurant on a piece of napkin. So they know how to build a good compiler, probably in their sleep. JVM expert focused on concurrency, so garbage collection is not a big deal. And they're faced with building a language which solves the problems perfectly. So they'll come up with something simple. As you progress, as you age, you will feel that you gravitate towards simplicity. Things that are simple to use, simpler to work. When I was young, I was just wrapping every 10, 15 days. I tried so many types of Linux distros. When I started working, I was like, okay, all Linux distros do basically the same stuff. So I just stuck with Ubuntu or Debian. Something like that. I just this works. Good enough, I can tweak it. They'll naturally gravitate towards that kind of a thing. And that is one of the reasons probably why Go is simple. So Go as a result came out as a simple language, simple to learn, and it's fast. They ensured it's the compiled language, not an interpreted one, and not compiled to bytecode, but to binary code, as in operating system can execute it directly without having to install another layer, another environment. Okay. All right. So, okay, when you come here, you basically enter the world of Google, the problems of Google that I already talked about. So, what does Golang actually do for you? Now, this is again technical only. Compiles fast, generates native code, and runs fast. Not just compiles fast, it also runs fast. It is garbage collected, but it's very intelligent. It does not have to stop the world garbage collection like Java does. So, if you have got a big Java program and you have got a lot of millions of small objects created, it will happen that at a certain time, if you have given that much space to your program, it has taken up a lot of RAM, and there comes the time of garbage collection. When that happens, Java will basically stop everything and then start with the garbage collection. So nothing works. While garbage collection is being done, nothing works. In Go, that is not the case. Garbage collector basically works alongside other Go routines that are already working. So it's much better. There's little to no magic. I mean, I like giving the example of C++ or Ruby. If you write something like you have x equal to a into b, right? Sorry. What? Uh, you write something like this, you can't say what is happening. These might be matrices. This might be a matrix, and this might be an operator overloaded. Okay, so this is what is called magic. You are trying to do something which is unnatural given its a normal state. When you look at a plus sign, you think that it's trying to add something. Maybe someone who has already programmed, they'll think, okay, might be trying to concatenate two strings. Like in Java, I think you use plus, right? But when you allow operator overloading to happen, you kind of introduce magic. And magical things are really difficult to debug. I mean, if this thing is erroring out, it will give a weird kind of error, right? Something like the matrix shapes are different or something like that. You'll be like, okay, what? These are matrices? That's what comes to mind when you're debugging. So Go doesn't have a lot of magic, so it's very easy to debug. Your IDE will be able to detect errors and tell you that, okay, this is probably not allowed, things like that. It's a little verbose, but forces you to handle things properly. And this is something I had written on Thursday. So usually, what people do is the people complain a lot about this way of doing things. That you return a value and an error, then you check for error is nil, and then you handle. And if you have a long function, you're doing this three times, right? Do one thing, do another thing, do another, yet another thing, and you're getting errors and you're checking errors everywhere. But if you look at any other language, right? Here, let's say it's Java, right? You do a big try catch block, and then you are going to do either this or you're going to do either this, right? In this case, you're just handling it poorly, right? You don't know what happened, what exactly was the problem. You have taken a big, an umbrella exception class, and every exception is, and every other kind of exception is a subclass of exception, so it will catch the exception, right? But you can't really tell what is what, like what kind of error that happened. But if you have to like catch every single error individually, like okay, the length of the integer was too much, or it was a big integer, I can't handle this. You want to say that you'll have to do this. You have to catch the integer overflow. I'm not sure whether this thing exists or not. Okay, whether it was a blank string or not, or something like that. I was just imagining a login screen vaguely where which I'm trying to solve here. So you'll have to do this. You're basically doing the same thing. You're writing if there is a particular exception, do this. If there is another exception, do this. If there is a third kind of exception, do this. Right? So if you want to program properly, where you take care of each case individually and you handle each case beautifully, give the correct error messages, you will have to do the work. You'll have to write all of this. You are doing the same thing here. Okay. So this is not an argument. I always used to program defensively. So when I wrote in Java, I anyway wrote like this. So it was not a big deal for me to transition to Go anyway. But yeah, this basically forces you to handle things properly. By the way, if you don't want to handle this, you know that whatever is happening here, if an error comes in, even if you ignore the error, it will be fine. You can just do this. Sorry, one single underscore. Sorry, yeah, this, and it will ignore the error. That's it. You can do stuff like that in Go as well, but it's not really recommended. If it is a fatal error, this can actually kill your program. It's a little verbose, but for you to handle things properly, that's what I explained. Comes with a unit testing framework built in the language, very useful. This testing framework helps you benchmark, tells you about number of allocations happening, which is useful in case of garbage collection. Um, the, the language comes with a formatter, not formatted, comes with a formatter, which is called Go FMT or Go format, and it will format your code in a certain way. Like if you try to do this, it's going to complain. It's going to say, sorry, I can't have the squiggly braces at the next line. It has to be at the end of the line. So Go formatter has got a certain standard. It's going to format your code in a certain way. Okay. So if you look at Other languages which don't have a formatter are like, I think Elixir has a formatter and Rust has a formatter, but Java does not. So if you look at Java code, it can be written in weird ways. C can be written in very different ways. You can write something like, for example, if um, x is this is C basically what I'm writing. If x is not equal to, it's not equal to 5, then you have to, let's say, print something, right? You can do this. This here you can also put in curly braces, but these braces are optional, right? So if you write this or you write this, it's the same thing, and it introduces an error, and you can say like go do something else. You can easily write this and make the mistake, because right now it's out of this condition, right? This will never happen in Go. Even if you write something like this in Go and you run the formatter, it will introduce this braces over here automatically. Okay, or at least you'll complain. I've forgotten what exactly is done. So all the code anywhere you pick up, any Go code that you pick up from internet, from your friend, wherever you get it from, it will have a certain format and it will have that format only. Okay. So it comes with a format. Cross compilation and being cross platform. So yeah, if you are using Windows, I think a lot of people said they were using Windows, right? We go to general. I have not seen that again. So let me check. Okay. Most people use Windows. But the code that you will write is going to run on Linux, 99%. Okay. So you have this machine, Windows machine, and you have to compile for Linux. So there are two ways of doing it. You take your entire source code and put it on Linux machine and compile there, or you can compile on Windows machine, get the binary that is compatible with Linux, and then put that binary into Linux, and it should work. And Go allows you to do that. Sorry, I stammered a bit. You can actually, even if you're running an OS like Windows on an Intel processor, you can still build for Linux running on an ARM processor. You can just pass in a bunch of environment variables. I think you can also do it using some build tags, I mean, build options, and it will be possible. So you don't have to like have a Linux machine to build on Linux. You can build for Mac OS, like Mac OS, Apple Silicon, M1, M2, M3, those on your Windows Intel machine. You can do that. And this is a beautiful solution to a very complicated problem, trust me. Um, and the last, but probably the most important part that Go gives you is maintainability. You write code 6 months down the line, you go there and you say, who is the idiot who wrote this? And I have done this myself. I wrote code, went back to that code, I think 6 or 8 months later, and I'm like, was this person drunk? Who has written this? So I go to git blame and I look at my name. Like, I wrote this. You are going to forget code. You're going to forget why you wrote what you wrote. Okay. It's very important that your code is maintainable. Someone else someday is going to look at it. They'll have to work on it, right? And Go gives you maintainability. And the reason I'm using this argument in maintainability, this is not exactly maintainability. Maintainability is basically being able to, upgrade your dependencies or support old dependencies. That's what maintainability comes to. But on a day when that happens, okay, they'll have to maybe alter your code. Go gives you backward compatibility to a very long time. Go 1.0 was, I think, released in 2014. I don't know when it was released. So, back, let's say Go 1.0 release date, March 2012. At this point, it's what? 12 years old. But you can still take a program that was written for Go version 1.0 and compile it today on Go 1.22 and it will run. They have offered more than 12 years worth of backward compatibility. No language does that. And this is one of the biggest problems in large code bases. Like I said, built for Google's problems, right? So, yeah, I think I have said the same thing. Yeah, yeah, about the same. Yeah. So this is more or less about Go. I have said the same things in many different ways in the previous session as well. And that finishes the introduction to Go.